Coming up on This Week in Radio Tech, fire protection for broadcasters. Our guest, Dean Wilson, has experience with both broadcasting, he's been on the air, and with fire protection. That was his whole career. Let's take a listen to what Dean Wilson has to say about fire protection for broadcast facilities next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionic Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we're talking about everything from the microphone to the light bulb at the top of the tower. I'm Kirk Harnack, coming to you from the Telos Alliance studio in Nashville, Tennessee. So glad to be here. It's a cold winter day here in Nashville. We've had kind of sunny and then cloudy skies. We had a little bit of snow last night. It is the January doldrums, as I call it. I just can't wait a few more weeks till the sun starts coming out and the temperatures start rising. But here we are talking about a topic that we normally don't cover on This Week in Radio Tech, but it's one that we all need to be a whole lot more aware of, and I'm sure there's things that we can learn. We're going to be talking about, well, tell you what, let me introduce our guest, and he'll tell you what we're talking about. I want to bring in my longtime Facebook friend. Got to meet him in person just once, and get to have him on the show now. Dean Wilson. Dean, welcome into This Week in Radio Tech.
Thanks, Kurt. Good to be with you. A pleasure. I'm a follower of This Week in Radio Tech. I think I've seen almost every episode. It's a joy to be with you today. Talk about fire protection for broadcast facilities.
Fire protection. And I tell you what, as an engineer, it's something I should think about, but I don't. Just to let our listeners know, I guess you and I met via Facebook. And then one time a few years ago, I was up in your neck of the woods around Erie, Pennsylvania. I was in the neighborhood, well, at least within an hour and a half drive. And I kind of surprised you. I stopped by to see you up there in Erie, and you graciously welcomed me in, and we got to spend a couple hours together. So that was great.
Yes, it was a great joy to have you visit. That was a high point of that particular summer. Look forward to perhaps that happening again once we get past this pandemic.
That would be great. You know, we got a little COVID in the house right now. My 10-year-old son tested positive earlier this week, and I just literally an hour ago had a visit from one of my daughters. She's a travel nurse. She's been working in Southeast Ohio in a COVID ward at a hospital. And I had some late Christmas gifts to give to her to drop off to take home to her family in Mississippi. So she stopped by, and of course she wasn't wearing the full PPE, but she had a mask on, and I did too. We're all quarantined right here, but she's going from the hospital in a COVID ward back to her home where her husband has tested positive for COVID. So it's at least they're all young, and but it does seem to be in a lot of places right now. Dean, have you been affected by this pandemic?
Fortunately, not directly, but Erie has had a rising caseload like a lot of places have in the last few weeks. We live in a retirement community, so we've been pretty well shut down for the last 9, almost 10 months. And we get out to go to church and do shopping and things like that. But otherwise, it's a pretty solitary existence. Fortunately, we can do most everything by Zoom or whatever. So
yeah. We since we're technically on quarantine, we've used Amazon, their fresh food delivery. We've used that just a time or two in the past. If there's something we needed and just didn't feel like getting out. I mean, actually pre-COVID, but we had $100 of the groceries delivered yesterday because we just didn't want to get out and shouldn't, because we're all technically quarantined here, and that service worked really good for us. In your neck of the woods, do you have something like that, fresh grocery delivery?
Yeah, most of our major grocery stores have a delivery service that they will provide for a suitably expensive charge, or they'll package it all up and you can drive up and they'll put it in the back of your SUV or whatever. So
good deal. Yep. Well, hey, to keep this radio related, You started in radio at a very tender age. Now, we're going to get to our main topic, which is fire prevention. And I tell you, when I start reading about fire prevention or hearing you talk about it, Dean, I get a little concerned that I've never been all that worried about it. I mean, I look for obvious stuff, but there's a lot of things that aren't very obvious that we're going to get to. But why don't you tell us just a little bit about how you got started in radio at a pretty tender age?
Well, Kirk, I was very fortunate. I was an only adopted child, and my parents were almost old enough to be grandparents when they adopted me, but they had certain educational aims in mind. So very early, they took me to the public library and got me used to roaming the stacks in the library and picking out something to read. And when I was about 10 years old, I came across Dewey Decimal System 621.384, which is the section for radio broadcasting. And I was very fascinated by that and took out a book that was published by the University of Michigan that was filled with photographs of radio station WUOM. And I read through that, and I took that book out over and over again. And there was probably about 12 or 14 other books on radio, including some about ham radio from the American Radio Relay League. I took all of those books out over and over again. 2 years later, when I was 12 in the seventh grade history, the teacher got ill, and they brought in as a substitute for just one day one of the high school history teachers, a gentleman named Dan Smith. And in addition to being a history teacher, Dan also worked at the local radio station. In fact, he worked in the evenings and did the 6 o'clock newscast. It happened to be a radio program my parents and I listened to every evening. It was called the Kendall News Review, sponsored by the Kendall Oil Company. And as Dan was calling the roll for the class, he came to my name and he said, "Oh, Dean Wilson, I would like to see you after class." And I thought to myself, goodness, what have I done? I've never met this teacher before. We were just a few minutes into the class. So I stopped at his desk on the way out, and he said, "Are you the Dean Wilson that's taken all the books in radio from the library out over and over again?" And I said, "Yes." And he said, "Have you ever been to the radio station?" And I said, "No." He said, "Would you like to?" And I nearly jumped off the floor. I was excited about that. So later that evening, my dad took me out to the radio station, and I spent the first time about half an hour with Dan Smith, watched him run the board. It was a 1,000-watt daytime, 250 night AM station, and it was a combo operation. So Dan was running the board and doing the announcing, and it was fascinating. And through him, I met several other staff members, including a gentleman named Bill Wynn, who wore a lot of hats for this small radio station. He was the program director, chief engineer, sports director, news director, and he took a liking to me, and he began to take me with him out to the station. And so very soon thereafter, I became kind of a fixture hanging out at the radio station. And eventually, I got an on-the-air shift when I was in high school, and I learned the radio biz. It was a fascinating time in my life. I had developed three kind of strands that my life was taking. The first was my evangelical Christian faith. Came from a very devoted Christian family, and the other strand, other than radio, was fire protection. In 1958, Our Lady of the Angels school fire in Chicago captured my attention, and I became very fascinated by fire protection. The National Fire Protection Association published a very detailed study of that fire. Over 90 children and several of the teachers died in that fire. And it profoundly affected fire protection in the United States, particularly in school buildings. So I wrote a letter. My mother had taught me how to type, so I typed the letter to the gentleman from the National Fire Protection Association who wrote that report. He happened to be a fellow named Rexford Wilson. He got the letter, had no idea that it was an 11-year-old boy that was corresponding with him. And so he wrote back. I asked him questions, and we began a correspondence. And it was actually quite a number of years went by before he realized he was writing to a kid. But so I had the strands of my faith, radio and fire protection, and eventually ended up making fire protection my career.
So that
Along
was
the way,
that was your career, fire protection.
yes, worked in fire protection all my life until I retired. Worked most of my time for a large, highly protected risk insurance company. I eventually spent the last years of my life there as the director of training, and then worked 5 years for a consulting firm until I retired. So that's my background. And I was assigned, because of my background in radio, I was assigned broadcasting and broadcasting facilities as one of the risks that I was responsible for, developing standards and rules and regulations and helping. We had a field staff of about 500 field engineers, and helping them learn how to inspect broadcast properties, which were very different. Most of what we insured were large industrial plants.
Mm.
So the larger broadcast facilities, there was a change of pace for our inspectors. So we had special training for them when they went into a broadcast facility.
I think you've got a presentation to give us, as if you were speaking with chief engineers, directors of engineering. And why don't we go ahead and jump into your presentation? It's not time for a commercial break yet, so let's get started in your presentation, and then we'll have to interrupt for some messages from our sponsors. But what would you like to begin telling us about fire protection, particularly for broadcasters?
Well, since the engineer at a radio station is basically a part of management, even though some engineers may not consider themselves, they do have facility management responsibility, and fire at a facility can be managed. And management has a very important role in the responsibility of making sure the facility remains as safe as possible. Part of the first step that management must do is to develop some goals, very site-specific goals for each facility, each broadcast facility. And on the screen, there's a slide of the typical goals that lead to enabling objectives. And we look in any facility, but particularly broadcast facilities, at 5 basic goals. We're protecting the people who occupy the building. And so we have a goal for life safety. And then secondly, we're protecting the property itself against the damage that a fire might cause. Thirdly, and this one is often overlooked by people, but we're maintaining the mission for the facility. Obviously, if a broadcast facility has a fire, either at their studio or at the transmitter site, or there are radio stations where that's combined, that certainly was the case in the radio station that I started in. If the fire puts the radio station off the air, the mission of the radio station has been affected dramatically. If you don't air spots, if you're a commercial station, you're not going to get any income. If you're a non-commercial station and you don't have broadcasting on the air, the people that support you are not going to be very happy about it. The fourth goal is preservation of heritage. And heritage is a strange word to use, but it's the best word to describe anything related to the documentation of the facility. For example, records. Or in the case of the broadcast facility, the preservation of heritage would include preserving the hard drives that might have the content that the radio station is broadcasting. And then the last goal is environmental protection, and this is a more global effect that a fire at the radio station might have on the environment where the radio station is located. Now, frankly, most of the time, a fire in a radio station is not going to have much of an impact on the environment, although if the fire, for example, a brush fire on the facility around the transmitting antenna, if it damages the guy wires and the tower comes down, that's certainly going to have some impact on the environment, as well as affecting the property protection mission continuity goals. So the setting of goals is something that management has to think through. It's very important in a broadcast facility that the engineer, the chief engineer or the engineering technicians become involved with management in setting those goals. And so typically we start by identifying who the stakeholders are. Who are the people that have an impact on that goal setting process? Obviously, the owners of the facility are stakeholders. The management team is a stakeholder. The insurance company that's writing the insurance for the facility, local fire code officials and fire department officials may be stakeholders, and others who have a stake in the safe operation of the facility. So you work with the stakeholders, uh, led by management of the facility and certainly involving the chief engineer to set the fire safety goals and objectives. Now, once you've set those goals and objectives, the management of the facility has to implement some kind of a program. And on the next slide, I list the typical kinds of programs that are developed by management to interlock and protect the facility. And you'll notice they're listed as management, construction, interior protection, exterior protection, special hazards protection, and protective surveillance. And the frame of all of that is the management program. What we're talking about, just briefly about each one of those, the management program is a declaration by management that they're concerned about the facility. We use the catchphrase concerned management interested in implementing an aggressive program of fire loss prevention and control. And we'll talk a little bit more in a bit about some of the things that management must do. The second is construction, substantial construction in good repair with adequate exposure protection. What that means is the facility has to be constructed so that it will prevent the spread of fire from the area of origin, generally to the rest of the facility, but certainly contained within that facility so the fire doesn't spread outside of the facility. And I would say this is one of the areas that's often been ignored in the creation of a broadcast facility. In looking at several hundred broadcast facilities over my career, I often have found very little thought given to the construction of the facility in a way that will contain the fire to possible areas of origin within the building so that they don't take out the entire interior structure. The next category is interior protection, and this is one that usually sends shivers up the spine of broadcast engineers when I first talk about it, because generally we're talking about automatic sprinkler protection. And somebody says, wait a minute, you're talking about water, putting water on my electronic equipment? But the truth is there are ways of drying the equipment out should it become wet. And the other misconception in a sprinklered building is, and we have Hollywood to thank for this, they think that anytime a sprinkler system goes off, every sprinkler head in the facility operates. And that, of course,
Right.
is not the way sprinkler systems work. Each individual head in a typical business occupancy sprinkler system is its own nozzle, and only the sprinkler over the point of ignition or the origin of the fire will operate. Sprinklers are designed to contain the fire to the area of origin. And we have a long track record of sprinklered broadcast facilities and computer facilities and other extremely high value electronic facilities where when sprinklers have operated in a fire, the equipment can be properly dried out and it doesn't affect the equipment at all. Probably the first lesson we learned was back in 1965 at a computer facility in West Palm Beach, Florida. This was a place where RCA at that time manufactured computers, and these were mainframe computers, and they had a fire in one of their test rooms where they had 8 computers, mainframe computers, up and operating. And we learned how we could use deionized water and warm filtered air to dry those computers out. RCA never sold any of those units, but they put them throughout the rest of their own facilities, and there were never any failures of those computers during their life. So we learned a great deal on that fire, and we've applied that since that time. The other thing that has to be kept in mind about sprinkler protection is that the accidental operation of a sprinkler head is generally about 1 in 16 million. So for a sprinkler head just to go off on its own is an extraordinarily rare occurrence. Now, there are some conditions. Somebody knocks into the sprinkler head, they could break it off. But again, in a broadcast facility, you often don't have that kind of possibility, at least not as much as you might do in, say, a warehouse building where lift trucks are driving around and things like that.
Or in a hotel room where there's a sign that says, "This is not a coat hanger."
Yeah, this is not a coat hanger, and that's
not for
in
hanging
fact
coats.
that's exactly right. And of
Yeah.
course, sometimes in a hotel room, the thermal element in the sprinkler head is a very sensitive element, so that it's designed to operate. It's operate very quickly, and so it's a little more sensitive to uh, somebody knocking it with a coat hanger. Take a look at that slide again, just to continue talking about those items. Special hazards is the identification of any hazard at a facility that is unique to that occupancy. And the biggest hazard that's unique at a broadcast facility is the enormous amount of electronic equipment. And there's many reasons why the proper installation of that equipment would be the benefit. Broadcast engineers well know that it's a lot easier to maintain broadcasting equipment if it's properly and effectively installed. So we don't have a lot of really badly hazardous operations going on at broadcast facilities. If the studio facility houses some auxiliary, if they store the lawnmower inside Studio A, or somebody decides to put fuel for the generator inside the building, there's a number of things where a hazard could be introduced. But basically, the special hazards in a broadcast facility are pretty much limited to the hazards associated with the powering of the electronic equipment. Exterior protection is kind of a catch-all. This includes the availability of someone to respond if there's a fire. And in most broadcast facilities, at least the studio facilities, there's probably a public fire department. And what gets important here is that the management of the broadcast facility should be inviting the fire department to visit their facility. And of course, the fire marshal's always willing to come, and everybody's afraid of what the fire marshal might find. But the people that should actually be visiting the broadcast facility are the first due engine company, first due ladder company. And so you try to arrange with the fire department to have the firefighters who are likely to respond to a fire at your facility. And since if it's a paid fire department, they're going to be operating in shifts. So you'll want to make sure that you rotate through the various shifts. And so all of the firefighters assigned to, say, Engine Company 4 get to come and look at your facility. If it's a volunteer department, that's going to be possible to get the vast majority of the volunteers to come in groups of maybe 5 or 6 at a time and take a tour of the facility and know where the shutoffs is for the electrical, the shutoff for if there's natural gas in the facility, those kinds of things. That's very helpful if they can do what we call a pre-fire plan for the facility. And then the protective surveillance, this is basically talking about detecting a fire. And in most radio stations, this is going to be some type of fire alarm system. In larger industrial plants, it might be a watchman making patrol tours when the facility is idle. But usually in business type occupancies, which is what the radio station is, some type of fire alarm system. And there's a lot of work that we can do with the fire alarm system other than detecting fire. For example, we can monitor the condition of the sprinkler system. Are the valves, the main valves to the sprinkler system open? The fire alarm system can monitor that. And then connecting that fire alarm system to some remote location that will monitor it, either a central station or a remote station or proprietary station, whatever the broadcasting facility happens to have available to it. So that's kind of the concept that management is going to use in order to move through the process of managing fire at the facility. They're basically going to be developing then some programs to handle the kinds of hazard. In the next slide, we show what we call the barrier against disaster.
Tell you what, we're going
And
to put a quick pause on that,
okay,
and
that's fine.
we're going to hear
Great.
from one of our sponsors, Broadcast Bionics, and we'll look at these specific ideas that you've got coming, including, I notice you've got a little topic you're going to talk about jerry cans eventually, metal or plastic containers. You've got some specific things that broadcast engineers are going to be able to put that information to use coming up, right?
Yep, absolutely.
Good deal. All right. You're watching This Week in Radio Tech. It's our 529th episode. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee. Our guest is Dean K. Wilson. Dean Wilson is a broadcaster, and he still does some podcasting. And Dean is also spent a whole career in fire protection. So he's got a program that we're going through right now, and we're going to have some specific examples of things to watch out for and things to do, things not to do at your transmitter and studio sites. So we'll have that coming right up after we hear from Broadcast Bionics. We'll be right back.
X-Screen 2, the simply amazing new way to control, screen and log calls using your Telos HX6, IQ6 or VX Talk Show systems, helping you to get the best calls to air quickly and easily. X-Screen 2 is a powerful touchscreen interface that connects alongside your VSET 6 or VSET 12 handsets and even enables you to screen directly on your PC using a USB headset or sound card. X-Screen 2 clearly displays the status of lines and hybrids, quickly captures caller details for screening and automatically stores a log of calls and easily manages station and show directories of important numbers. There's also a scheduling clock and chat window for instant messaging and visual talkback to other X-Screen workstations on the system. As soon as a line rings, the caller's name is displayed, if they've rung before, and we can look up their location. X-Screen also usefully shows how many times they've called before and when they last called. You can add alerts to identify nuisance or persistent callers before you've even answered the call. To route a call to the VSET or headset, simply click on the handset symbol, exactly as you would use the button on the VSET. Using the other icon on the line, we can hold the call or route the call to a hybrid. Selecting an alternative device will change the icon key so you'll always know the destination of the call. The tabs on the right-hand side provide more information and control the selected caller. We can add this caller to a caller directory or create a manual entry for someone we call regularly. Calling someone is as simple as just clicking dial on their entry. A free version of X-Screen is included with your HX6, IQ6 and VX Talk Show system. The full version of the software enables the caller database, directories and alerts and other cloud-based features. All Telos customers can try the full version for 3 months by downloading the free trial. More information is available by contacting Broadcast Bionics or your local dealer.
X-Screen from Broadcast Bionics is really cool software. Works perfectly well with Telos phone systems, and a lot of people use it. Check out that and other things from Broadcast Bionics. Go to bionic.radio, and find out more about Broadcast Bionics. Really appreciate their sponsorship of This Week in Radio Tech, and you should check out their really cutting-edge technology, their software solutions for getting things done around your radio station, especially as it regards social media. Just great tools from Broadcast Bionics. Clever folks. All right, I'm Kirk Harnack. It's This Week in Radio Tech, and Dean Wilson is my guest. Dean, we were right in the middle of moving on to the next portion of your talk about fire protection in broadcast facilities. Take it away.
Okay, Kurt, thank you very much. On the screen is a slide we call the barrier against disaster. And basically what it is, it's it shows the kinds of programs that management might develop in order to manage change. You'll notice, if you can see it clearly enough, that the bricks in the wall are held together by management of change, and that's the major thing that a broadcasting facility has to do. Broadcast management team usually is significantly involving the engineering people, the chief engineer and the other technicians. Whenever a change is going to be made in a facility, to manage that change, to make sure that whatever the change is doesn't somehow put the facility more at risk. And this can take a lot of forms. And for broadcast facilities, it'll often have to do with the way the utilities, changes to the utilities, changes that might be made to some of the way that employees are allowed to operate. In the rare case, for example, that hot work, which is basically welding and cutting operations, might have to be brought in to the inside of a broadcast facility. There are programs and codes and standards that cover how those kinds of operations can be done safely. When we were talking yesterday, Kurt, you mentioned having to silver solder at one time. And there are some things that a broadcast engineer needs to do if they're going to do that kind of flame work. Those types of programs need to be thought through ahead of time so that the change that represents can be managed. I want to talk briefly about codes and standards because they're one of the things that's really helpful in talking to a broadcast engineer is, unlike some other people that we talk to, broadcast engineers are very familiar with codes and standards because of all of the codes and standards that the broadcast engineer has to deal with from the Federal Communications Commission and a number of other bodies that they might have to deal with locally. So on the next slide, I talk about some of the major codes and standards that affect broadcasting in the United States in particular. Basically, most jurisdictions, most towns and states and other political jurisdictions in the United States have some form of model codes that they rely upon. In the United States now, the major code-making body for model building and model fire codes is the International Code Council. For many years, the United States had three basic building code organizations, and they were all merged in the early 1990s into the International Code Council. Each jurisdiction or each area might take, say, for example, the International Building Code and modify it slightly and adopt it. For example, I live in the state of Pennsylvania, or the Commonwealth of Pennsylvania, and they have taken the International Building Code and they have adopted it and made a few minor changes to it and apply it throughout the Commonwealth. The building code is basically and was basically originally created so that a fire would always be contained within the building where the fire started and not spread to other buildings. Everybody has probably heard of the Great Chicago Fire. The Great Chicago Fire is what we call a conflagration. A fire started in one building and it spread to other buildings and spread to other buildings, and pretty soon the entire city of Chicago was on fire. The building code intends to keep the fire to the building of origin. So it's a minimal code. It doesn't address the very specific concerns that a particular occupancy might have. It does a good job for what its purpose is, but people need to understand it's a minimum code. It also wants to make sure that the occupants of the building can escape from the building. And so the protective features that are built into the international codes are basically oriented toward those two objectives. In order to get very, very specific about unique hazards or unique aspects of fire protection, the model building codes look to the organization, the National Fire Protection Association, or NFPA. And the National Fire Protection Association has developed a large number, there's almost 300 of them, consensus codes and standards that deal with all kinds of things. For example, there's a code that deals with fire alarm systems. There's a code that deals with sprinkler systems. In a little bit, we're going to talk about gasoline and fuel storage. There's a NFPA 30, a flammable liquids code. And all of these codes and standards in the United States are developed by consensus using experts recognized in the field who meet together and develop a consensus standard. They make proposals, they examine them, they vote on them. It's a very voluntary process, which is a little bit different than a lot of the rest of the world. There are code-making bodies, for example, the International Electrotechnical Commission that develops codes throughout Europe and parts of Asia. The International Standards Organization, also operating in Europe and parts of Asia. But in a lot of other countries other than the United States, the government develops the codes and standards. Here in the United States, it's all done as a consensus basis and overseen by an organization called the American National Standards Institute, or ANSI. And they're overlooking and overseeing the consensus process that the various codes and standards making organizations use. The National Fire Protection Association codes, as well as the model building codes, look to nationally recognized testing laboratories to make sure that the products that are used in fire protection are safe. The major laboratory in the United States is Underwriters Laboratories, and most broadcasting facility people are familiar with the UL listing of a lot of the electronic equipment that they have. UL is headquartered in Northbrook, Illinois. It has some field offices around the country. It has some other testing sites located out on Long Island and down in Research Triangle Park in North Carolina, and also in Santa Clara, California. But they develop testing standards on the testing of various types of equipment to make sure that equipment can be operated safely. So with all of that consensus standards making process, we end up with codes and standards to handle such things. For example, what do I do with the fuel I have to have for my generator? Now, it may be that your standby generator is fed by natural gas. And if that's the case, NFPA 58 is a standard for the use of natural gas. And it also can, there's a standards that are used for liquid petroleum gas and liquefied natural gas. There are standards for the installation, maintenance, and use of these materials. NFPA 30, I mentioned a moment ago, is a standard for flammable liquids. And so if you have a gasoline engine-driven generator, then the way that you store, maintain, and use the fuel is going to be covered by NFPA 30. Now, it's important to mention that even the generator itself has its own National Fire Protection Association standard. NFPA 110 is the standard for emergency and standby power systems. So any broadcast engineer who anticipates installing a standby generator either ought to obtain a copy and study that document, or hire a consultant familiar with the proper installation, maintenance, and use of generator and standby power systems, because there are a number of very important safety requirements for the installation of a generator. You may think, well, we just pour a pad and somebody brings a generator and we hook it up. But actually, to do it in the safest possible way, there is this NFPA standard to follow and to use. One of the things that's helpful to understand is if you're going to choose a new generator and you have a choice between gasoline and diesel fuel, I would always urge you to choose diesel fuel. Diesel fuel is a lot less of a problem from a fire standpoint. And let me just explain briefly. Gasoline has a flash point of minus 40 degrees Fahrenheit. What that means is at minus 40 degrees below 0 Fahrenheit, gasoline begins to give off ignitable vapors. And so virtually in every situation that we would experience in the United States, gasoline is always in the process of giving off vapors that can be ignited. So compared to diesel fuel, Diesel fuel is basically kerosene with additives. Kerosene has a flash point of 105 degrees Fahrenheit. By the time you put the additives in that diesel fuel has, it bumps the flash point up to about 126 degrees Fahrenheit. So as if I had a container of diesel fuel and was holding it here in my hands, it's not giving off any ignitable vapors. It has to
Really?
be heated. It has to
I
be heated to 126 degrees before it gives off vapors that will ignite. So
I
diesel
did.
fuel is
Wow.
a lot safer. Yeah.
Yeah, I didn't realize that at all. 126 Fahrenheit. So yeah, in most storage situations, there are no flammable vapors coming off of diesel. But as you said, minus 40, even at minus 40 or just above that, gasoline is putting off vapors.
Gasoline
Goodness.
is virtually always putting off vapors that can be ignited. So
Yeah.
um, and there's all kinds of concern with those ignitable vapors. Obviously, the biggest concern is keeping them away from an ignition source, something
Yeah.
that's going to have enough joules of energy to ignite the fuel. The Flammable Liquids Code limits, first of all, I need to say, and I've mentioned it, but I haven't specifically pointed out, radio stations fall, as far as the building code is concerned, fall under the category of business occupancy. Every occupancy has a code classification. And common ones, for example, are uh, a building that's used to house a theater, for example, has a classification for that type of occupancy that's different than the occupancy of a radio station or office building. But a radio station is treated basically as a business occupancy. And so under that occupancy classification then affects the fire protection requirements for a whole wide variety of different items. In the case of the Flammable Liquids Code, a business occupancy is permitted to have within that occupancy only 10 gallons of gasoline or diesel fuel. And those 10 gallons have to be stored in a safe manner. The container that contains gasoline or diesel fuel cannot exceed more than 2.6 gallons. And that's kind of an odd, why did 2.6? Well, what they did a number of years ago when everybody thought we were going to metric, they converted everything in the codes and standards to metric measure. So when you reconvert back to gallons, it comes out 2.6 gallons. And so any container that you're going to put gasoline or diesel fuel in within the building can't exceed more than 2.6. And the maximum that you can have has to be no more than 10 gallons, and it needs to be stored in a safe manner. And I have a slide of a UL listed flammable liquids cabinet. Now, basically, this is a fairly substantial metal cabinet, and there's actually provision in this cabinet to vent it to the outside so that if any vapor does get released inside the cabinet for some reason, it can be vented to the outside. Now, for the business occupancy, the Flammable Liquids Code does not require the cabinet to be vented to the outside. There are occupancies where it does have to be vented to the outside, but it's there. And if I were putting one in, I would probably vent it to the outside just to take advantage of that safety feature.
Well, and who likes the smell of gasoline vapors anyway? Nobody really likes that.
Right. And the door shuts tightly, and basically what you're doing is you're containing the vapors in the cabinet. Now, somebody in discussion that you and I had early on when we were planning this a week or 2 weeks ago, whatever it was, somebody talked about jerry cans. And so I've got a photograph of a jerry can. Most people know what they are. And so that's the next slide. Take just a brief look at it. Developed by the German military just before World War II and then adopted by the American military. It's a very common way of moving fuel around. A lot of people don't realize that certain jurisdictions for example, have adopted a color code. The state of California has adopted a color code for jerry cans. And they, for example, they want gasoline to be in the color red. If you're going to put diesel fuel, they want it in the color yellow, and kerosene in the color blue. And that color code has been adopted by a number of other jurisdictions, a number of other states, and so on. The jerry can is a relatively safe container if it's UL listed, because one of the things that's very important, you'll notice if you look at that cap closely, the cap is spring-loaded. And the advantage of that spring-loaded cap is that if that jerry can is heated up in a fire, that spring-loaded cap will release and let the pressure that builds up inside the can escape. If you had a tight container, the pressure could build up in the can if it were subjected to a fire to the point where the can would rupture, and we would have what's called a boiling liquid expanding vapor explosion, or a blevy.
That doesn't sound good. That doesn't sound good at all.
It doesn't sound good at all, and it's not good at all. The force of that explosion creates a pressure wave that's very damaging, but it also spews the gasoline or the flammable liquid all over the room. So I'm not a big fan of jerry cans, but the key to using, and I'm going to show you the container I like in just a moment, but the key is to, whenever you're transporting fuel, you want to make sure that the container is secured. So if you're going to transport it, it's better if it's in the bed of a truck as opposed to the trunk of your vehicle. In fact, unless you live in the northernmost reaches of Alaska, where it's always pretty cold, I wouldn't put it in the trunk of a vehicle, because in the trunk of a vehicle, you could get it warm enough that the pressure might build up, and pretty soon you'll have a trunk full of gasoline.
Before we take a look at the can that you like, let's hold through the commercial break for that. I want to give a little tease to that. So jerry cans, not so great. By the way, I just bought 2 jerry cans, and I'm not entirely impressed with the sealing mechanism. They do have the 2 forks that come down and pull in and pull a gasket down, but I'm sure there's different qualities of different jerry cans, but I want to see what Dean does recommend for storing gasoline coming up. This Week in Radio Tech, episode 529. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee. I want to give a quick shout out to our friend Ray Topp at radio-guide.com. That's Radio Guide magazine. And you'll find some of the best articles in Radio Guide. It's not necessarily today's news. It's today's techniques. It's how to do engineering right at broadcast facilities. So if you want to check them out online, go to radio-guide.com and check out the latest issues that they have online there. Really appreciate Ray Topp and his efforts with Radio Guide. All right, we're going to be right back after a word from Vox Pro. Hang on.
Yo, what's up? Live from NAB 2018. Hey, it's Caden. You need to check out Wheatstone and Vox Pro 7.1. The upgrades are amazing. If you're a jock, if you're a talent, producer, whatever, morning show, everyone knows Vox Pro, everyone uses Vox Pro, everyone loves Vox Pro, but now the features for this year, 2018, on 7.1 are amazing. If you're using version 4.5.6 and you go to 7, this is exactly what you're missing right here. The features are a game changer. It's going to cut down your editing time by like 80% depending on what you use Vox Pro for. And with version 7.1, introducing unlimited Practic button bars right here, hotkeys right here. I'm going to show you coming out of a song.
Bad things. It's a lot of bad things that they wish and they wish and they wish and they wish.
So you're coming out of your song?
Yeah.
Start your next song right here. It's basically an entire production room right on Vox Pro. So it's the Vox Pro we know and love with a ton more features. And now this is the ultimate game changer right here. Effect macros. So instead of hitting your effects button bar and going up here using your mouse for every effect, you do it right here with one click of the mouse, and you're going to cut down your editing time by about 80% without even touching this new sexy black controller. Check it out right here, Wheatstone Vox Pro 7.1 at NAB in Vegas 2018.
And Vox Pro 7.1 is still the cat's meow for producing phone calls, even longer form programming, taking remotes and getting them prepped for air. So check it out. Broadcaster General Store is where you want to get your Vox Pro at bgs.cc. Or you can do like I do, because they're really friendly people there. I just talked to Travis there today at Broadcaster General Store. The phone number is 352-622-7700. They do good phones at Broadcaster General Store. Their whole business is designed for you. Just give them a call and talk to them. Tell them what you need. They'll tell you if it's in stock, how long it'll take to get there. If maybe you're open to other suggestions if what you want isn't available. That's typically what I did when I was doing a lot of contracting. I'd call and say, I got a grocery list here. And they'd say, yep, got that. Ooh, that's about a month out. Do you want a substitute? Really helpful at Broadcaster's General Store. Check them out at bgs.cc. All right, Kirk Harnack here, along with Dean Wilson on This Week in Radio Tech. And Dean told us that jerry cans for carrying and transporting gasoline, not his favorite. Dean's got a lot of experience with fire protection. So, Dean, what is a better solution?
Okay, Kurt, this is my preferred method of transport of fuel. This is a UL-listed safety can. And you can buy this today in both metal and plastic. And I'm not very impressed with the plastic can, even though it is UL listed. I like the metal cans. They're much more substantial. They'll take physical abuse a little better than the plastic. One of the things about the plastic is, of course, if they are subjected to a fire, the plastic will eventually melt, and all of a sudden you're feeding the fire with the fuel that's in the can.
Yeah.
There are a number of features about this. This particular slide shows some of those, but one of the things I want to point out again, we have this pressure relieving cap, so that if this can ends up being subjected to an exterior fire, as the pressure builds up in the can, it will vent very safely through that spring-loaded opening at the top, and that will minimize the amount of contribution to the fire the liquid inside will make. The other big advantage to safety cans is something called a flame arrestor, and I have a slide of that next.
Okay.
If we go to the next slide, this is looking down into that opening, and basically what you're looking at is a removable metal screen. Sometimes when people see this for the first time, they think that they're looking at some type of a filter to trap dirt that might be in the fuel, but this is a flame arrestor. And the whole idea is that if for some reason this can is subjected to an exterior fire and the flame gets very close to that opening, the flame cannot move down inside the can. That flame arrestor basically is a giant heat sink, and you will be able to ignite the vapors, but you won't be able to get the flame down inside the can, where it might, depending upon how full the can is, it might get in the vapor space. And once you get to the lower explosive limit, the mixture of fuel and oxygen, you can have an explosion. So this is interestingly, this is not required by some jurisdictions, but I always think that when you buy a safety can, you should buy one with the flame arrestor. And again, the key to all of these, whatever container you buy, you absolutely must buy a UL listed container, because it's been subjected to quality assurance tests at UL to make sure that will function under a variety of circumstances and situations. So,
good to know.
The next subject, tying in again with codes and standards, I want to talk about are fire extinguishers, because every facility is going to have. Yes, thank you for this. The other thing, I would have missed this, and this is very important. when you are dispensing, especially gasoline, but it could very well apply to diesel fuel as well, you need to bond the metal safety can, or if you're using a jerry can, the metal jerry can, you need to bond it to the same bonding that the generator has. If the generators are usually bonded to ground, and you need to have a strap, a metal strap that goes from the generator to the safety can. And what this will do is this will prevent the creation of any static electric charge that might generate a spark. And believe it or not, there are circumstances where liquid flowing out of an opening in a safety can generate enough static electricity to create a spark with sufficient joules of energy to ignite the fire. So by bonding it, you're draining off any static electricity that might form. Some people say, well, if I use a metal flexible spout and make sure that's in contact with the metal opening of the fuel tank, I'm effectively grounding it. I've seen situations where that is not as positive a ground as this grounding clamp and strap. So I recommend strongly that you use the grounding strap.
I sure have seen a lot of static buildup from those plastic bed liners in pickup trucks. And people often may transport, even if it's safety can, transport in the back of a pickup truck to go get it filled up with gasoline at a gas station. And those plastic bed liners can sure make a heck of a wallop static electricity.
Yeah. Yeah, they certainly can. The best, you should never leave your container in the bed of the truck. If you're using safety cans, you should bring it out, set it down on the ground, and usually you'll get enough contact with earth through even if it's concrete, because most concrete has rebar in it, you've got a good enough contact to drain away any static electricity that might be there. Okay, let's move on and talk about fire extinguishers, because every facility is supposed to have fire extinguishers, and choosing the right fire extinguisher is something that's very important. To do that, again, we go back to the fact that the fire extinguisher must be UL listed. And the fire extinguishers are designed to be effective for certain types of fire. And I have a slide that shows the classifications of fire extinguishers. I think it's the next slide.
Probably formatting it. Oh, there it is.
There it is. Basically, we classify fires from a fire extinguisher standpoint in either class A, B, C, or D. Class A is wood, paper, basically material that when it burns, cellulosic material that will produce an ash. Class B is the flammable and combustible liquids. Class C is any fire involving energized electrical equipment. The key word there is energized, because once the power is shut off, then the category of fire, the classification of fire, reverts back to whatever is actually burning. And Class D is combustible metals. This is one that a lot of people have never heard of, but we have metals like titanium and zirconium and lithium. Those metals, when they burn, they actually will liberate oxygen from water. So in extinguishing a fire in a significant quantity of titanium, particularly, for example, if it's in some kind of chip form, you put water on that, you're going to liberate the oxygen, and the fire will burn more intensely. So we have some very specific extinguishing powders that are listed for use with combustible metals. Radio station people probably aren't going to have to deal with that very much. But the typical Class A extinguisher is going to be generally a water-based extinguisher. I prefer the 2.5-gallon water extinguisher to the ABC dry chemical extinguisher, because basically I want to keep a dry chemical extinguisher out of a broadcast facility. I don't want it anywhere in the broadcast facility. And the reason for that is the powder in either in a Class BC dry chemical powder extinguisher or an ABC dry chemical powder extinguisher will play havoc with electronic equipment. It will insulate any contacts. When I was a very small boy, back in the mid-1950s, there was a fire in the Western Union building in my hometown. A lot of people don't realize that at one time, Western Union maintained communication lines between their facilities and had switching centers very similar to the switching centers that the telephone company has all over to switch telephone calls back in the day when it was done by either step-by-step relays or crossbar relays. And they had a fire. It was actually a wastebasket fire in this Western Union office, and it got into one of the wire racks where all of the lines were coming in. And they used to insulate the wire in those wire racks with paper. And so they had a fire going, and the local fire department had just gotten the very first dry powder extinguisher. And so they went in and they used the dry chemical powder extinguisher to extinguish the fire. And Western Union spent the next 6 months working basically 3 shifts, 24 hours a day, 7 days a week, cleaning the contacts in the switching relay. They had to bring in a portable switching unit in the back of a tractor trailer to the load because that switching center was completely shut down. So I want to keep dry chemical extinguishers out of a broadcast facility. I want to use water for Class A fires, and for the electronic equipment in racks, I want to use carbon dioxide extinguishers. Carbon dioxide extinguishes the fire by smothering the fire, replacing the oxygen in the immediate vicinity of the flame front, and it completely dissipates when it's done, and there's no residue and no harm to the equipment. Halon extinguishers also could be used in electronic equipment. If you're going to use a Halon extinguisher, though, you want to use a Halon 1301 extinguisher instead of a Halon 1222. Halon, of course, is a halogenated hydrocarbon. Halon, I think the Halon name is actually trade name by DuPont, who created the first halogenated hydrocarbon in the U.S. And the numbering system talks about the number. The 1301, for example, has 1 carbon atom, 3 fluorine atoms, 0 chlorine atoms, and 1 bromine atom in the mix that forms the halon liquid, which is under pressure and is discharged as a gas or as a fine spray. 1222, 1 carbon, 2 fluorine, 2 chlorine, and 2 bromine. And that's where I get nervous, because chlorine is not something that we want to have around electronic equipment, even though it's been tested and listed for that purpose. I'm very nervous about introducing liquid chlorine into broadcast facility electronics. So if you're going to use
Dean, I'll put a link to this Halon 1301 in the show notes, but I noticed that, and I may be able to say it, Halon 1301 is Bromotrifluoromethane. How about that?
Indeed, it is. There is concern about the use of Halon products. There was a protocol that was signed back in the late 1990s called the Montreal Protocol that was trying to get rid of most of the halogenated hydrocarbons. And so there have been a number of other extinguishing agents that have been developed. We call them clean agent systems. And there are not very many of them. In fact, I'm not sure if any of them have found their way into hand-portable extinguishers. They're used more in extinguishing systems. In some of the larger broadcast facilities where we have huge rooms full of racks of broadcast equipment, either the networks that are generating satellite content and so forth, we may protect an entire room with a clean agent system. It's quite expensive, and before you do it, you have to, before you install such a system, you have to do a test to make sure that the room will be able to contain the vapors without a lot of leakage. There's actually what we call the door fan test, where we put a pressing unit in the doorway and see if the room, how long the room, what kind of leaks there are in the room, to make sure that it will contain the extinguishing agent. Those clean agent systems, including Halon, all extinguish fire by bringing the chain reaction of combustion. Water, of course, extinguishes by cooling, carbon dioxide by smothering. The dry chemical powders break the chain reaction of combustion, and in the case of the ABC dry chemical powder, will form a skin on Class A materials, wood, paper, so forth. And I've already given my preferred pitch of keeping dry chemical out of broadcast facilities.
Yeah. But you do like CO2, right?
Yeah, CO2, it's a gas, and mostly you're going to be using it in a localized fire situation. CO2 is going to be possible to put out a wastebasket fire with it, although it's not listed for that. It's listed as a Class BC extinguisher. But I'm thinking of the CO2 extinguisher in the equipment rack areas where a lot of high-value electronic equipment. I've seen lots of dry chemical extinguishers in those areas because that's what they bought. They bought ABC dry chemical to put it throughout the facility, thinking they wouldn't have to. They didn't want any water. They're afraid of water. And
Right.
so they got ABC dry chem, but that could wreak havoc with any contacts of any kind of contacts. And of course, broadcast equipment has a lot of contacts.
Oh, yeah. And so dry chemical may get the fire out quickly with apparently little damage, but from what you're saying, you're going to pay for it in the long run because you'll have contacts that no longer work.
Yeah, and cleaning those contacts could be a very arduous task. And so just for the sake of the broadcast engineer, I wouldn't want that. I wouldn't want that to happen.
We've got to take our final break and come back with a tip. So of all the great advice that you've given, and maybe anything that you haven't been able to give yet, we haven't talked a whole lot about change. A facility can be designed properly from the get-go, and over time, over years, over decades, people make changes. Whether it's maybe they wall off a door, and that door may have been an important part of the original fire plan. There's all kinds of things that can take a facility from being relatively fire safe and properly designed to, whoops, we accidentally did something, or we did something we didn't think it had an implication on fire. And sure enough, it does. So Dean will be back with a tip in just a minute. Our show this week in Radio Tech, it's episode 529. I'm Kirk Harnack with Dean Wilson, fire protection expert and former broadcaster. So that's cool to have those two talents in one man. We'll be right back after this word from our friends at Max Connect. Be right back.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It's also given us the ability to expand as needed in a secure fashion.
I'll tell you, the tech support from Max Connect Wireless is fantastic. I've got a couple of examples right here. One of them is a Cradlepoint 4G LTE router and modem. This one has 2 SIM cards in it. I've got a Verizon and AT&T, and this is a Max Connect PepWave 4G LTE router. Again, the key here is not what brand the router is, not what brand the 4G LTE modem is, but the key here is the SIM card from Max Connect Wireless, because Max Connect has made agreements with the major carriers to get prioritized data from the cell towers. And so that means that your data gets through on a priority basis over whether there's 10 users or 1,000 or 10,000 users. Probably wouldn't be that many on a single tower, but there could be. Thanks a lot to Max Connect Wireless. Check it out at maxconnectwireless.com. And they are really great with tech support. If you get your router and you got a little problem, you're not sure how to use it, or you need to open a port, they are very helpful there at Max Connect Wireless. Somebody else who's helpful is my friends at angryaudio.com. Remember, don't get mad. get angry. This is one of the most useful devices there's been during this whole pandemic when people are operating from home, disc jockeys, radio talent, people doing interviews. You're operating from home, and maybe you've got a small audio console, maybe you've got one of those Rodecaster Pros, or you've got a little Behringer or Mackie mixer, something like that. And you, or even if you've got a real professional audio console, a broadcast style one, you need to get callers on the air. Well, do you really want to bring in a separate POTS line and get a hybrid just for that to put callers on the air? You probably not. Get this. This is the Bluetooth audio gadget from Angry Audio. And this will connect right to your cell phone. It's got a switch right here for pairing, a spring-loaded switch. Pair your phone right up to that, and then carry on your conversation. It's got input and output jacks right here on the back. You hook that up to your audio console, whether it's a pro console or semi-pro console. There you go. There's a picture of the back of it and the front. And you can also, if you need to wire your phone in, it's got a jack on the front to do that. Convenient 3.5 millimeter tip ring sleeve jack for a wired connection. But, you know, that Bluetooth connection is great. And they're using the latest Bluetooth in here, automatically switching between the conversational mode, where you get appropriate audio quality two-way, or the one-way stereo mode. So you're playing from your phone into this device and then to your audio console. So if you've got some music, you got an interview on your phone, you can play it right through there and it's going to sound great. Remember, Angry Audio is also your source for Studio Hub. Studio Hub is in business because Angry Audio took care of everything for you. They saved the factory, they saved the jigs, they saved the employees, and they're making Studio Hub now again. And you can get genuine Studio Hub adapters. This is the famous cable adapter here from XLR to an RJ45, and you wire the rest of your facility with Cat5 cable. Here's the other style that's the RJ45 male plug going into whatever connector you want. Hey, look, you can even put these together. Now I've got XLR to XLR. Well, let's see, that wouldn't work. Probably get the male for one of the ends, and then you'll have a patch cable. Check it out from any of your favorite dealers. Ask for Studio Hub, the genuine quality, the stuff that works. They've been making this stuff for years, and they know exactly how to get an audio cable to go into an RJ45 jack. Thanks a lot, Angry Audio. Check them out at angryaudio.com. You can check out the Bluetooth audio gadget, headphone amps, all kinds of gadgets and gizmos to make your studio, your home studio, or your radio station studio work a lot better. Thanks a lot. All righty. We're about to end things up here with Dean Wilson. And Dean, I'm sorry, we're just about out of time, but maybe you can give us about a minute-long tip or trick. What's the most important thing we might pull away from this?
The management of change plays a key role in maintaining the facility over the long haul. So whenever a change is going to be contemplated in the facility, think about the implications that change might have to affect the safety, the fire safety of the broadcast facility. That's going to be very important to crank in. We could illustrate that in many ways, but I'll simply say that I went to a radio station. The fellow that was showing me around said, you know, I don't know where it's coming from, but we've noticed there's a smell of gasoline, and I'm kind of concerned about it. And he was taking me through, and we opened a door into what had been the break room, and there was the lawnmower was sitting there. Somebody had decided that was a good place to store the lawnmower, and the lawnmower was leaking, and there was actually a small puddle on the floor of gasoline that had been leaking out of the tank since they brought it in a couple of days before. So think about what you're doing. Launch planning is key, and the way that you maintain the facility, you have to manage change.
Wow. Then there's so many things that can change, and you don't realize what a hazard it is. And even more dangerous, I suppose, if you come into a situation where a change was made before you got there and it was a dangerous change. And you kind of engineers need to be on the lookout for things that look hazardous. And Dean, if you want to bring an expert in, where in the phone book do you look for a fire protection expert? How do you find somebody to give a look over your facility?
There are a number of consulting fire protection engineers, and basically you would try to look for a number of look in the phone book for a fire protection engineer. There are large national companies that have people in most major cities around the country. And if somebody wants to give me a call, you can find my contact information on my website, deankwilson.com. I'd be happy to put you in contact with someone in your area.
Good deal. All right. Dean, thank you very much for all this information. I know this. You could talk for a lot longer about all this topic and tell stories and what you found that is safe and dangerous and yeah. But people's lives depend on good fire protection as well as facilities and continuing business. So, Dean, I want to thank you for being here. Appreciate you taking the time and appreciate you sharing your expertise with us.
My pleasure. I'm honored to be on TWiRT.
All right. Well, we're honored to have you. All right. I'm Kirk Harnack, and we've been glad to have you along with us. You can always check out our website at thisweekinradiotech.com. If you're watching this on YouTube, and if you're watching it not live, you probably are watching it from YouTube, give us a like, would you? Subscribe to the channel. That'd be just great if you would. I want to say thanks to Suncast, our producer, who takes us through every show and really makes things work well. Suncast, thank you very much. Also, thanks to Andrew Zarian, the founder of the GFQ Network. We'll see you next week on This Week in Radio Tech. Bye-bye.